Welcome to this explainer. So, I was recently looking into how the AP Computer Science Principles exam handles the concept of collaboration, and it turns out it's not just some fuzzy, feel-good soft skill that's nice to have. Our goal today is to completely demystify that idea. We're going to transform collaboration from a kind of abstract concept into a concrete, highly testable formula that you can totally master for your AP exam. By the end of this explainer, you're going to know exactly how the test makers think about teamwork.
Okay, let's dive into this roadmap. We're going to cover 1. Why collaboration truly matters. 2. Good versus bad teamwork. 3. Designing for the user. 4. The developer's collaboration toolkit. And finally, 5. Acing the AP exam.
Section 1. Why collaboration truly matters.
You know how pop culture always shows coding as this lone genius typing away in a dark basement, completely isolated from the rest of the world? Yeah, it's time to totally debunk that myth. For the AP exam, the absolute baseline definition of collaboration is working with others to create a computing solution. It is definitely not a solo endeavor. Modern coding is an active, highly communicative, shared creation process. It's really about merging different minds to build something that one person simply couldn't build alone.
And this brilliantly illustrates the core philosophy behind why tech companies and, the AP exam cares so much about this. The more diverse the team, the more complete and fair the solution. When you blend different backgrounds, experiences, and perspectives, you're actually creating a really powerful defense against biased software. Think about early facial recognition software that struggled to recognize certain skin tones just because the development team wasn't diverse enough to catch it early on. You aren't just writing code, you are actively preventing unfair or limited solutions by leaning on the incredibly varied life experiences of your teammates.
So when you bring those different perspectives together, it naturally sparks genuinely better, way more creative ideas. And this leads directly to a more user-focused design, right? Because a varied team better reflects the varied people who will actually use the software. That diverse foundation, as we just saw, acts as a sort of shield to reduce bias. Plus, you get to share strengths. Maybe one teammate's eye for graphic design perfectly complements another's absolute genius in back-end logic. The end product is just far superior to what either of them could do alone.
But here is a major plot twist. And it's a classic AP exam trap, so listen closely. Warning: collaboration does not replace testing, debugging, or validation. Even if you have the absolute best team in the entire world communicating flawlessly, your code is still going to have bugs. Having multiple sets of eyes on a project is amazing, absolutely crucial even, but it does not give you a free pass to skip rigorously testing and validating your code.
Section 2. Good versus bad teamwork.
Now, what's really interesting about this slide is, well, we've all been in that awful high school group project where one person ends up doing literally all the work the night before, right? On the exam, that independent isolation under the guise of teamwork is a massive red flag. Good collaboration means frequent communication, utilizing shared tools, actively giving and receiving feedback, and genuinely working together on ideas. Bad collaboration is working completely independently, having zero feedback loops during development, or just having one poor person do all the integration at the very end.
The core takeaway here is that collaboration is about continuous interaction, not just dividing up the work. True teamwork isn't just taking a massive project, chopping it into 3 separate pieces, retreating to your separate corners, and stapling it all together at the finish line. It is a continuous, completely interactive loop of sharing and building.
Section 3. Designing for the user. Software doesn't exist in a vacuum. It exists to be used by actual people, which leads to a really important question you'll see pop up. Why involve users at all? Why not just let the brilliant engineers figure the whole shebang out on their own? Well, we involve them because they give us real-world feedback that we simply cannot simulate in a lab. They help identify actual practical needs and glaring usability issues that a developer might be totally blind to. And of course, they bring completely different perspectives to the table. We cannot just guess what users want. We have to actively seek their perspectives to make software that actually works for them in the real world.
So the crucial point is this direct relationship. Developers design for users, so users absolutely must be part of the development process. Think about it. If you're building an app for senior citizens to track their medication, but you don't actually consult any senior citizens, your interface is probably going to be super confusing, the buttons will be way too small, and the app will just fail. The user is a completely vital collaborator.
Section 4. The developer's collaboration toolkit.
To actually turn all that philosophy into reality, developers rely on a digital backbone.
To stay out of that bad collaboration trap we talked about earlier, teams rely on shared, synchronized platforms. They use shared documents like Google Docs to brainstorm together. They use version control systems like GitHub to manage the actual code so they aren't accidentally overwriting each other's work. And they use continuous communication tools like Zoom and Slack to ensure everyone stays on the exact same page.
Let's move to and see how this builds into specific, everyday techniques. First up is pair programming. Think of it kind of like a driver and a navigator in a rally car. Two people work at one computer on one piece of code. One person physically types, while the other strategizes and reviews on the fly. Step 2 is code reviews, where teammates actively read and give feedback on each other's code to catch any mistakes early on. And Step 3 is iterative feedback. This means you don't just get feedback once and call it a day, you improve the project step by step, constantly looping back to make it better and better. But to actually use those tools and techniques effectively, you need these essential team skills: communication, a deep respect for others' ideas, conflict resolution, and consensus building. Listen, your technical brilliance means absolutely nothing if you can't resolve conflicts calmly or build a consensus with your peers. These aren't just nice-to-haves, they are non-negotiable requirements in computer science.
Which gives us this beautiful mathematical formula directly from the source material. Good teamwork equals technical skills plus people skills. The developer's formula is about bringing both halves of that equation together perfectly. You absolutely need the coding knowledge, for sure, but you equally need the human touch.
Section 5. Acing the AP exam.
All right, let's turn everything we've structured today into your ultimate study checklist. On the exam, you're going to be specifically asked to identify the exact benefits of collaboration, recognize the difference between effective green flag teamwork and ineffective red flag isolation, understand on a really deep level why team diversity matters in preventing bias, and explain exactly why user feedback is critical to the whole development cycle. If you can do these 4 things, you have completely mastered this topic.
I want to leave you with this final, kind of provocative thought as we wrap up this explainer today. Your code might compile perfectly, without a single syntax error anywhere. But without diverse collaboration, without user feedback, without differing perspectives, is your computing solution truly complete? I'll let you think about the true value of human connection in computing. Thanks so much for joining me today. Keep studying hard, and we'll see you in the next one.